So let me have this example, this new example. So suppose we have this recurrence relation a sub n equals a sub n minus 1 plus 6 times a sub n minus 2. Now the two initial conditions are that a sub 0 is equal to 1 and a sub 1 is equal to 2. So it is a recurrence relation in a way that this a sub n is defined by its two previous terms, a sub n minus 1 and 6 times a sub n minus 2. Okay, so assuming that you want to find for a sub 2, so that means that it is defined by a sub 1 plus 6 times a sub 0. And we know that a sub 1 is 8 plus 6 times a sub 0, which is 1. Okay, so this will be equivalent to 14. And for a sub 3, okay, so we have a sub 2 plus 6 times a sub 1. So a sub 2 is equal to 14 plus 6 times a sub 1, which is equal to 8. Okay, so this will be equal to 62. Okay, now what is the degree? So step 1 is find the degree or order of the recurrence relation Rn. Okay, so a sub n is defined by its two terms, a sub n minus 1 plus 6 a sub n minus 2. So these two terms. So we can then say that k is equal to 2. Okay, so note, if you remember, this is how we can have the solution. So find the order, followed by finding the characteristic equation, and finding the roots, and finding the constants. Okay? So you can review in the previous video if you still don't understand what that is. So next would be step 2. And step 2 is find the characteristic equation. Okay. So, and we can do that by the form a sub n equals r raised to n. So what we'll do is just to, in this r, so we simply have to substitute or replace that with r sub n, r raised to n. So we will have r raised to n equals r raised to n minus 1 plus 6 times r raised to n minus 2. Okay, as you can see here, we just replaced a sub n with r sub n, a sub n minus 1 with r raised to n minus 1, and a sub n minus 2 with r raised to n minus 2. So then we are going to transpose everything to the left hand side. So we have r raised to n minus r raised to n minus 1 minus 6r raised to n minus 2 equals 0. So let me check if I'm still sharing my screen. And next is, we are going to simplify this by dividing by r raised to n minus k, or this n minus the degree k. And we know that the degree k is 2. So this would be r raised to n minus 2. So we'll have r raised to n minus n minus 2 and r raised to n minus 1 minus n minus 2 minus 6 r raised to n minus 2 minus n minus 2, and that is equal to 0. And this will be simplified to r raised to 2 minus r minus 6 equals 0. So then this will now be our characteristic equation. Okay? This is CE, or characteristic equation. Now our next problem is to find the roots. Find the roots of CE. Okay, so how can we do that? So we already have r squared minus r minus 6 equals 0. So what we can do is to factor out this characteristic equation. So we have um, the factors are r minus 3 times r plus 2 equals 0. Okay? So if you multiply r minus 3 and r plus 2, it results to r squared minus r minus 6. So if r minus 3 is equal to 0, the root for r will be 3. And if r plus 3 is equal to 0, then r will be equal to negative 2. Okay? So we then have these two roots of the characteristic equation 3 and negative 2. And for step 4 is to find the coefficients. Okay, so if we have this recurrence relation in sub n equals a sub n minus 1 plus 6 times a sub n minus 2, and we have the characteristic equation r raised to n equals r raised to n minus 1 plus 6r raised to n minus 2. So by theorem 5, the closed form solution is a sub n equals alpha 1 r1 raised to n plus alpha 2 r2 raised to n. Okay, we're in this r1 and r2 are the roots of BC. Okay, so we already know our roots. R equals 3 and r equals 2. So suppose this is r1 and this is r2. Okay, so we simply have to substitute that into our equation. So we have an equals alpha 1 times 3 raised to n plus alpha 2, and r2 is negative 2. So it is negative 2 raised to n. Okay, and now our problem is to find the coefficients. And these are the alpha 1 and the alpha 2. So paano kaya natin mahanap yun? So what we are going to do is to use our initial conditions. So if you remember, our a sub 0 and our a sub 1 is equal to 2. Okay? So we can compute for a sub 0. We know that a sub 0 is equal to 1. So we substitute that into this equation, or this equation rather. So we have a sub 0, n is equal to 0. So we will have alpha 1, 3 raised to 0, plus alpha 2, negative 2 raised to 0. Okay, so this will be equivalent to alpha 1, since 3 raised to 0 and negative 2 raised to 0 is equal to 1. So we'll be left with alpha 1 plus alpha 2. And we know that a sub 0 is also equal to 1. So we have this function. Okay, and we can also compute for a sub 1, since we know that it's equal to 8. So we have a1 is equal to 3. So substitute that from here. So that will be alpha 1, 3 raised to 1, plus alpha 2 times negative 2 raised to 1. So that will give us alpha 1, 3 plus alpha negative 2. Okay, or can rewrite it as 3 alpha 1 plus, or minus 2 rather, minus 2 alpha 2. Okay, and now we know that the A1 is equal to 8. So we can write A1 equals 3 alpha 1 minus 2 alpha 2 equals 8. And we have this another na equation. So still the question is, what is the value of alpha 1 and alpha 2? So we will compute it algebraically. So we have alpha 1 plus alpha 2 equals 1. And A1, which is 3 alpha 1 minus 2 alpha 2 equals 8. So from here, paano natin mako-compute si alpha 1 and alpha 2? So to make it easier, we can multiply this whole equation by 2. So we will have 2 alpha 1 plus alpha 2 equals 2. Alpha 1 minus 2 alpha 2 equals 8. Okay, so now, madali na siya. I-cancel out. So we will be left with 5 alpha 1. So we simply have to add this up, equals 10. So, and then alpha 1 is equal to 5 divided by 2, which is equal to 2. Okay, and we already have a value for alpha 1. And for alpha 2, so we can simply use the equation alpha 1 plus alpha 2 equals 1. And we know that alpha 1 is 2 plus alpha 2 equals 8. 1 pala? 1. 1. So alpha 2 is equal to 1 minus 2. So alpha 2 will be equal to negative 1. Okay, so we now have the values of our constants. So the last part would be to step 5. Write the closed form solution. Closed form. So we have again an, if the RR is a sub n equals a sub n minus 1 plus 6 times a sub n minus 2. For the closed form, we have an equals alpha 1 r1 raised to n plus alpha 2 r2 raised to n. So, and we know that our root 1 is equal to, our alpha 1 is here, is 2, and the root 1 is equal to the one that we have computed earlier is 3. So that will be 3 raised to n plus alpha 2 is equal to negative 1 times r2, which is negative 2 that we have computed. So negative 2 raised to n. So ito natin kinuha. Yung R1, R2 from the step 3, and alpha 1 and alpha 2 from the step 4. Okay. And we can further simplify it. So 2 times 3 raised to n minus negative 2 raised to n. So let us try to verify. Assuming na a sub 2, ulit, ulit yung initial condition. Yung A0 is 1. A1 is equal to 2. Okay. So yung A2 is equal to A1 plus 6 times A0. So A1 is 8 plus 6 times A0, which is 1. So this is 14. So for A2, it is equal to 8, A3 pala. A3, na-complete na pala natin yung A3. Is equal to A2 plus 6 times A sub 1. So yung A sub 2 is 14 plus 6 times a sub 1, which is 8. So this is equivalent to 14 plus 48 is 62. And i-check naman natin kung tama ba yung closed form solution natin to this recurrence relation. So we have compute natin diretso yung A3. So A3, that is 2 times 3 raised to 3 minus negative 2 raised to 3. So 2 times 27. 2 times 27 minus plus 8. So negative 2 raised to 3 is 8. So 2 times 27 is 54 plus 8, 54 to 62. And both of them have shown or given us the same value. Okay, and that is all. So we have found the closed form solution to our recurrence relation. Kaso iba